Welcome to this tutorial on building a simple neural network in Python. In this tutorial, I will walk you through the basics of creating a neural network using TensorFlow. Don't forget to like, share, and subscribe, and also write your comment in the comment section of this video tutorial. And this video, I will walk you through a step-by-step guide how you can create a simple neural network with TensorFlow in Python. If you are new to artificial neural networks in TensorFlow, you can watch the previous video tutorials. I have briefly explained about neural networks, TensorFlow, and Keras as well. You can find the links in the description box of these video tutorials. So let's try to implement a simple neural network with TensorFlow in Python. Here's a step is to build a simple neural network in Python using the popular machine learning library, which is called TensorFlow. So the first step is install the library, TensorFlow library. You can use pip install TensorFlow. So the latest TensorFlow library supports Keras framework. So you don't need to install Keras separately. So you can install the latest versions of TensorFlow on your Jupyter notebook. By the way, Google Colab supports TensorFlow. You don't need to install TensorFlow on Google Colab if you are using it. Okay. The next step is import the necessary libraries. The necessary libraries are TensorFlow, so you have to import TensorFlow as a short name here, and also import NumPy. This is common for any machine learning or artificial intelligence development. So you can import NumPy as NP. Okay, now go to the third step. The third step, if you don't have training data, so you need to create or generate synthetic data for training the model. For learning purpose, I will show you how you can create a training data using NumPy. So in this case, you can use NumPy to create training data. You can randomly seed, and you can create the X variable matrix np.random.rand n random number 100 random numbers and step by one, and the Y is 3 by X plus 2 plus 0.1 times np.random.rand and 101. So this is the X and Y variables, which contains the synthetic data to train our model. Okay, you can run this and you can make sure. So here I have generated some synthetic data for training purpose, X and Y, where the relationship between X and Y is. So the relationship between X and Y is Y equals 3X plus 2 plus noise. The last one is noise. So this is the relationship between X and Y. So the Y is this one. We are going to predict the Y based on the relationship I have created in this function. Okay, now define the architecture of neural networks. This is very important to define the models. The model here, TF TensorFlow.Keras. Keras, you don't need to install separately because the latest versions of TensorFlow supports Keras. Keras is built on top of TensorFlow because it is an API. So the TensorFlow API is Keras. So here you can call the sequential and compass the TensorFlow.Keras.layers. You can create layers in the sequential function, and you can pass the inputs and the dimension. Input shape is 1. This is okay. So you can run this. The model is, or that this is the artificial neural network architecture. Actually, if you watch the introduction to neural networks video, you can clearly understand the architectures of neural network. I recommend you to watch that video. You can find in the description box of this tutorial. So this tf.keras.sequential is a simple way to build a neural network layer by layer, because artificial neural network is like human brain. It has layers. Actually, there are 3 layers: input layer, hidden layers, and output layers. So it allows to create models layer by layer in a step-by-step fashion. Each layer has parameters. Yeah, the weights, the functional, forward propagation, backward propagations. So each layer has parameters that are learned during the training process. The sequential model is the most straightforward model to use, but it is limited in that it doesn't allow you to create multiple layers or multiple inputs or outputs in this case. Because this is a simple neural network, I just try to walk you through from the very beginning to the advanced levels of building artificial neural networks, specifically deep learnings. So the other is inside this sequential, I just create a dense. The neurons are the nodes, or the dense is a type of layer used in the neural network. It is the basic layer in a neural network, also known as a fully connected layer. So each neuron in a dense layer receives inputs from all neurons in the previous layer. So the dense layer performs a simple linear transformation on the inputs, followed by an activation function. So in this example, I just created a dense layer with 1 unit. One unit means 1 neuron, and specified an input shape of 1, indicating that the input to this layer is 1-dimensional array. It has 1 input and 1 output. So this is the model or the architectures of neural network. Once you define the architecture of neural network, you can go to the compiling the model. Okay, that is the 5th step. And the 5th step, you can call the model dots compile, and you can pass optimizers. Optimizer std, and the loss function. Yeah, mean square error. So that is the 5th step. So this model.compile function configures the learning process for the neural network. Specifically, it uses a stochastic gradient descent, which is SGT, as an optimizer, and the mean squared error, which is as the loss function. Now training the model. So the 6th step, once you compile the model, you can train the model. It is common for like other traditional machine learning model. So you can use model.fit to train the model and pass the x and y matrices x, y, and here there is another parameter which is epochs. You can specify the number of epochs here. So an epoch refers to here the training is the model is trained here. So we have 100 epochs. So an epoch refers to one complete pass through the entire training dataset during the training of a model. So each epoch consists of one forward pass and one backward pass of all the training examples. So the model.fit function is used to train the neural network model on the provided training data x and y for a specified number of epochs. Here I specified 100 number of epochs. During each epoch, the model updates its parameters based on the training data and the configured loss functions and optimizers like stochastic gradient descent, and the loss function is mean squared error. So training for multiple epochs helps the model to learn from the data and improve its ability to make accurate predictions on unknown or unseen data. So that is very important to specify the epochs because it helps the model to train or learn from the data and improve the abilities to make accurate predictions on the test data set. Okay, so far so good, and we continue to make prediction. Once the model is trained with 100 epochs in this example, we can make predictions on unseen data or new data. So let's say X test, let's generate a new unseen data NP dot array. Let me provide 0.2 and 0.4 and like 0.6. Okay, let me put in this. Okay, now let's make prediction. The model dots go to predict, and I pass X data I have generated here, and let me try. Okay, now let me check the prediction result. Yeah, it is 2.6, 3 point something, and this. Those are the predictions of the new data based on the model trained on the X and Y data sets previously. So I hope you found this tutorial helpful in understanding the basics of neural networks. Don't forget to subscribe to the channel for more exciting tutorials and content on machine learning and artificial intelligence. Thank you for watching, and I will see you in the next video.